Hello and welcome to EE 233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at our sort driver. This is part of a longer series involving the sort version 1, sort version 2, and sort version 3, as well as other videos that look at specific applications of sorting algorithms. Our goal in this video is to do a little bit of cleanup in our sort driver, as well as combining some of the features that we explored in other videos. So this video makes the assumption that you have already watched the sort version 1, sort version 2, and sort version 3. If you have not yet done so, you should go back and watch those videos. So to begin with, what we want to do is we want to look at our main. And the first thing that you should notice is that I have now incorporated all three of the sets of switches or sets of options for handling our different sorting functions. And particularly if you notice sort of some commonality between the three is that all three of the possibilities accept 5 arguments. So our C is equal to 5, as well as the switch or the argv square brackets 1 differs merely by the version that we wish to run. And that was intentional because we wanted to essentially have a way of testing a family of sorting algorithms. So the only cleanup that we need to do in main, in addition to bringing the extra switches in or the extra options, is in the last part or in the else part of our if else end, we simply want to include an else. In other words, if somehow the user entered in some combination of switches that we were not prepared to handle, we simply want to make a call to our help function. Now, if we take a look at our help function by right-clicking and navigating and going to the declaration, then we probably also want to take a second to make some improvements in the help. Now, at this point, you should have seen a pattern between the sort version 1, sort version 2, and version 3. So it should be pretty straightforward to update our help by simply copying and pasting, with the only change being the version number. And at this point, we should have an up-to-date help function. And as you add additional functionality to your executable, you simply update the help. Now, delving into a specific version of our sorting algorithm, many of the changes that we're going to make in our version 1 should also be applied to our version 2 and version 3. So what I'm going to do is I'm going to focus on making the changes in version 1, and then going to introduce a place for you to pause the video. And then you want to come back and rejoin me on the other side to verify that you have made all of the changes. Now, for this video, we are also going to assume that we are using the sample_01.txt. This file will be provided to you. And more importantly, it will allow for you then to have a consistent way to test to make sure all of your sorting algorithms are working, and more importantly, sort of rank the efficiency of them in a relative fashion. And also note that we are going to rank them in rather measure their efficiency in a sort of a crude way, meaning that we're going to just use a rather practical approach to measuring them. So the first thing that we want to do inside of our sort algorithm is address a few things that we did not address earlier, or rather that we intentionally ignored. The first thing that we intentionally ignored was the availability of the input file, meaning that we just blindly assumed that the input file was going to be available to us, or that it was able to be open. That is not the case. So the first thing that we want to do is we want to check to see if our input file pointer is equal to null. And specifically, we want to check that our input file pointer is not equal to null. And if it is not equal to null, that is when we actually want to read in our file. Otherwise, what happens is we may have our executable crash. So carefully inserting then the if, else, and then we want to close the file only in the scenario in which we actually successfully opened it. Under the else branch of our if else, we simply want to printf and message back to the user. In this case, we're going to say error failed to open, and we're going to use %s as a placeholder for our file name. So in this case, it's going to be our input file name. Now, we could do some additional error checking. Particularly, we could check before attempting to open the file that the file name actually has a valid file extension, is at least length greater than a minimum number of characters, and so on. But I'm going to leave that part for other videos. Rather, this is, if you would, the bare minimum that we would want to expect to do, and that is that we would check to make sure that we were successfully able to open the file. Now, note here that I also have a count variable, and my count variable keeps track of the number of items that were read out of the file. Notice now we do not have to check to see that something was read out of the file because we have initialized the count equal to 0. So effectively what we can do is we can leverage the count variable now further to make sure that we even have enough rows or enough data to begin our sorting algorithm. Put another way, there's basically no reason to attempt a sort unless we were successfully able to read data out of the file. And so what we can do is we can very carefully move our code, starting with our if checking the order, all the way down to the end where we handled the unhandled enum in our else, as well as the writing of our output file. So in other words, literally everything down to the F close of our output, we can then remove and move that into the if branch of our input checker. In other words, making sure that we have successfully opened an input file. So once again, paste that and then take a second to go ahead and tab it over so that it's properly nested. So basically everything here can be tabbed over, and the only time we would even attempt to do a sort would be if we were successful at reading data from the file. Now, you'll notice then that we still have the loop counter. And so here, if you notice that the loop counter will print out the total number of times that a loop was ran. Well, if you notice at the beginning of our function, we initialized the loop counter to 0. Put another way, basically, if we were unsuccessful at opening the file, then the loop counter would still be equal to 0. So it's a way of essentially providing user feedback, letting us know that something went wrong. Now, I'd like to take this concept just a little further by the introduction of one more temporary variable. And what I'd like to do now is, instead of using exit success and exit failure, what I would like to do is I would like to provide an integer feedback that indicates sort of the number of items that were out of place in the array. Now, there's a number of ways that we can go about doing this, but for this particular example, we just want to sort of provide, once again, kind of a metric, if you would, of how many changes were needed to be made. And so what I'm going to do is I'm going to create one more temporary variable. It doesn't really matter where you place it, but we're going to make it an integer, and we're going to call it a change counter. And like the loop counter, we are going to initialize it equal to 0. And the idea here is that the change counter is going to simply be a metric that measures about how many things were out of place in our array. So basically, every time we find a new value, whether it's a low value or a high value, depending on whether we were doing ascending or descending, we simply want to increment this change counter. And we want to do so both in the ascending portion of our algorithm as well as the descending portion. Now, instead of then returning exit success or exit failure, what I would propose that you consider doing is simply returning the value in the change counter. And this basically will give you an integer count of the number of times that you found something that was out of place. So if, for instance, our change counter variable is still 0 at the end of our function, it simply means that the file that was inputted turns out to be in the ascending or descending order, or what was requested by the user. For instance, the file may have already been in the ascending order when the user requested the order be ascending. Okay, so once again, it's just a way of tracking what our algorithm does from the calling function. The second thing that I want to do now is I want to take a look at our loop counter. And the loop counter is intended to be sort of a relative comparison of the efficiency of each one of our algorithms. Now, the algorithms, the sort version 1, version 2, and version 3, all share the same code, specifically for reading in the data from the file, as well as transferring the data from the unsorted to the sorted chunks, as well as writing the output file. And this probably now makes sense why we have this, even though it is extra in at least one of our algorithms. So the intention is that we sort of made all things equal. So what I would like for you to do is to increment our loop counter anywhere we have either a for or a while loop. And so inside of the loop that reads the data from the file, we would put a loop counter increment. Inside of our nested for loop, so in other words, this for loop, we would put a loop counter. And notice that this is outside of the if statement. So basically we increment the loop counter inside the nested for loop. And since this is nested, it's going to run not only for the inside, but also for the outside loop. And then everywhere we have a for loop to transfer the data from one array to another, we increment the loop counter, as well as outside of our outer if here, or excuse me, rather our inner if, but in line with our outer for. So basically, every time the outer for loop runs, we want to simply increment it. We do this for both the ascending and the descending branches, since essentially they do the same thing. So basically what I'm going to do is everywhere I run my inner for loop, I increment the loop counter. Anywhere I increment, or excuse me, anywhere I move the data from one array to the other, I increment my loop counter, as well as outside of the inner for loop, but inside the outer for loop, I also increment my loop counter. And then lastly, also in our writing of our files. So when we transfer the data from one array to the other, as well as writing the data to the file. So you want to take a second at this point to make sure that you have your loop counter incremented everywhere correctly. Now, we're going to go ahead and build it just to make sure that we've not introduced any bugs. And then what we want to do is we want to go back up to our main, and we want to utilize not only that loop counter, but we also want to utilize that change counter. And that change counter then is going to be captured in the results. So in other words, since it's the return value from our sort version 1, we want to simply printf a value that specifies the number of changes or the number of out of place values in our array. So how about if we word it that way? So the number of out of place values, and that is just simply going to be a %d. And we simply want to then show that value, the result. So we do the same thing for whether it's ascending or descending. At this point, we can go ahead and build once more. And you want to come back to your command window. And we want to go ahead and run our sort version 1. Whether we do the ascending or the descending first, it does not really matter. But in this case, you'll see that the loop counter runs 19,230 times, and the number of out of place values were 285. Now remember that that out of place value increments every time a new lowest value is found. And so lowest value being tracked in this case because it's ascending. Now we're going to go ahead and look also briefly at the descending, and it seems like we have, I chose the wrong sorting function. Haven't gotten to that one yet. Let's go back to our sorting of version 1, sort version 1. You'll see that it runs roughly the same number of times. In other words, the loop counter is 19,388. The number of out of place values or 254. So it seems like you could say that it was somewhat better suited for descending. In other words, there were less moves required or less things out of place than with the ascending. All right, so this is going to be the place then that you want to pause the video, and you want to go back and make the equivalent changes now to your sort version 2 and version 3. Particularly, you want to go ahead and implement this change counter, as well as implementing the logic to handling the null file pointer, and then come back and watch the remaining part of the video where we actually compare all of our sorting algorithms. All right, welcome back. So hopefully you've managed to get all of the changes implemented. You'll notice here that I am now in my sort version 2. I have created a new temporary variable. And hopefully you can just quickly see as I scroll through my code here where I've added both the change counter as well as the loop counter. And specifically the loop counter goes everywhere there is a loop of any type, as well as in the outer while loop, there is a single increment for the loop counter, as well as inside the inner while loop in our search function. And then anytime we have found a value that was essentially out of place, we incremented the change counter. Likewise, in the descending, the code is essentially, or the changes to the code should be identical. And then lastly, a loop counter should go into any of your for loops, and then the change counter should be returned by the function. Likewise, in our sort version 3, we do the same thing. We add a change counter. The loop counter goes inside of each one of our loops, including the loop that reads the contents of the file and our nested for loops. And the change counter only goes when there is some out of place value found. Now, you could have argued that we could have put the change counter only in the condition where found is equal to true, but I wanted to keep track of exactly how many values were out of place and every time they were out of place. So once again, different metric, you could argue both ways that you would only put them in the change counter inside of there. And that's perfectly fine. That's essentially a different way of measuring it. We do the same thing now with the in the descending. Make sure that you have your change counter whenever you find an out of place value, and the loop counter everywhere you have a loop, including when you reorganize or transfer the unsorted to the sorted, as well as write it to the file. And then lastly, you want to make sure that you are returning your change counter. Now, we're going to go ahead and build this real quick, and hopefully we don't have any typos, any compile errors. And then what we want to do now is we want to just come and briefly test whether our version 2 and version 3 are working correctly. So I'm going to start off with ascending, and I'm just going to focus on ascending. So first we start off with the sort version 1 ascending, and you'll see that it's 19,230 with 285 out of place values. We then want to switch to our version 2, and you'll see that my loop counter has 10,200, but notice that I am not yet specifying the number of out of place values, which means simply that we have not yet updated our main. And so what you want to do is you want to carefully take the printf statement that we generated for the sort version 1 branch, and you simply want to bring it down now to the sort version 2 examples, as well as for the sort version 3. All right, so let's recompile this now, and let's see if we've got this handled or it'll got this working. And so you now see that the second algorithm has 10,200 iterations as opposed to 19,230. But however, it finds a lot more out of place values. And specifically what it does is it finds the same value out of place multiple times. That doesn't necessarily mean that those values are going to be moved every time. It just means that they are identified as being out of place many, many, many more times. And then likewise with sort version 3, we see now that the third version runs 5,349 times, and only 242 values are out of place. So I think at this point, hopefully you're a little bit surprised, or at least pleasantly shocked, to see how much more efficient then that third algorithm is. It's sort of a hybrid between the two. And if you think about the algorithm in sort version 3, it's not too terribly surprising that it's a little bit more efficient because it only switches or swaps the two values that were identified as the lowest value, meaning the lowest indexed value rather, and then in the ascending example, the lowest value. Okay, so basically far more swapping occurs. All right, so what we want to do now is to wrap this up. We want to come up with a nice way of presenting this in it. We would like to see all of our sorting algorithms run at once. And there's a couple of ways that you can go about doing this. You can either A, do this with another else if and create a switch that would essentially run all of your sorting algorithms. But then as you add new sorting algorithms, you would also have to update the code to reflect that. A better alternative would be to just simply create a batch file, and that's what we're going to do. So what you want to do now is you want to go over to your Windows Explorer, and you can see here that I'm in my MinGW directory. And what we're going to do is we're going to create a batch file. Now, it's not going to be the best named batch file, but for lack of some creativity here, we're just going to call this one sort_demo.bat. And Windows is going to prompt you and ask if you would like to change the file extension. The answer is yes. And then at this point, you just want to drag it and drop it into NetBeans. Now, currently there is nothing in there. What we would like to put in there is going to be our various cases here that we want to test. And we're going to start with the sort demo.exe and the sort version 1. So I'm going to copy and paste this into my batch file. And at this point, what I want to do is I want to go through all 6 of my options. But in order to do that, I need to specify which version of the output file. We could overwrite our output file, but I would like to also capture the output file and be able to determine which sorting algorithm ran which output file or which generated which output file. All right, so the other thing I would like to do is I would also like to be able to create a history, if you would, of us running our batch file. And to do that, we simply want to pipe what would otherwise be on the command line, printed to the command line. We want to be able to pipe that to an output file. And we can simply append from there whatever additional switch combinations we want to test. So the first thing that we want to do is we want to append then to an output file, and let's call this one sort_demo. And we're going to keep consistent here, but we're going to change the file extension to .out, meaning it's going to be a text file with the .out extension. So everything we want to do now is going to append that file. Particularly what we're going to do now is we're going to test out the descending option. And this is still going to be of version 1. And then we want to then switch this now from version 1 to version 2, and I'm going to go ahead and paste version 3 here. And then you just simply want to go in there and carefully change everything that says version 1 to version 2, and then later on to version 3. It's basically just a little bit of fancy bookkeeping. Now, the only other thing that we want to do is every time we run our batch file, we want to delete the output file. So we're going to say delete sort_demo.out. Now, essentially when our batch file runs, it's going to delete the output file and it's going to recreate it and append whatever was printed to the console to the output file. So let's give this a shot now. We're going to come back over to our command window. We're going to type in CLS and then dir, and you'll see there's my sort_demo.bat. And let's give this a shot and see how it runs. And so notice now that it ran all 6 combinations of our sorting function, as well as if you take a look now using dir, you'll see that I have several more versions of my output text files. So I tell you what we're going to do real quick, just to clean this up slightly, I'm going to run del star.txt. Now don't be afraid here. We're basically just going to delete our text files, but we want to be careful because we also don't want to delete our sample o1.txt. So what we can do here is we can specify the ascending. So basically everything that has ascending in it can be deleted. All right, so let's see here. We're going to have this right here. And now when I type in dir, you'll notice that I have kept my sample underscore o1.txt, but I've lost all of my output files that had the word ascending in there. And we want to follow this up one more time with the descending. And you can do this from Explorer as well. There's no magic here. It's just I like to show you some tricks here. All right, so now we're down to the 4 files that we absolutely need. And technically, we don't even need our sort demo.out. So we could go ahead and delete that from here as well. Just be careful not to delete your sample01.txt, because otherwise we're going to have to go find another copy or recreate it. All right, so now that we're down to the 3 files, we want to rerun our batch file. You notice that it runs 6 times, or runs our sort demo 6 times. And there we have a nice collection of output files. But in this particular case, the one that is going to be the most interesting to us is going to be that sort demo.out. And you'll see now a comparison of your loops first running ascending and then descending. So we're comparing the version 1 ascending and the version 1 descending. You could add some additional comments in your batch file and improve the clarity here. But hopefully from this, you can see that your version 3 is significantly more efficient for this particular file. And also, interestingly enough, note that the loop counter for the ascending and the descending is actually the same. All right, so hopefully, as always, you found this video useful. If you have any questions or comments, do not hesitate to email me, and thank you for watching.